When the outcomes of a situation are equally likely, the probability of an event is the ratio of the number of outcomes in the event to the number of possible outcomes in the situation. Numbers used to represent probabilities range from 0 to 1. If an event must happen, the probability is 1. If an event cannot happen, the probability is 0. Well, here's a standard dollar coin, and most of you know that for just about any coin, if you flip a coin, one side comes up and one side is face down. Generally, we call one of the sides heads and the other side tails, as shown here for the dollar coin. So the probability that a flipped coin comes up heads is one way out of 2 possible, or 1 to 2. Probability of a flipped coin coming out tails, also 1 to 2. Now let's flip a coin twice, 2 consecutive coin flips. One outcome is heads followed by another heads. Or it could be heads followed by tails. Or tails followed by heads. Or tails followed by tails. 4 possible outcomes when flipping a coin twice. Well, let's answer some questions. What's the probability that both flips come up heads? Well, we can see that. There's one way out of the 4, or 1 to 4 is our probability. Probability that each flip is different. HT and TH are both different outcomes. So 2 ways out of the 4 have different outcomes. So the probability that each flip is different is 2 to 4, or in lowest terms, 1 to 2. Now let's look at all the ways you could flip a coin 3 times. Well, there's all heads, 2 heads and a tail, heads then tails then heads, heads followed by a pair of tails, then a tails followed by 2 heads, tails, heads, tails, 2 tails and a head, and finally all 3 tails. And here are some questions. Probability of all flips coming up tails. Well, you can see there's just one way out of the 8, or 1 to 8. Probability that each flip is different. Not possible, because if you flip a heads, then a tails, or a tails, then a heads, then your third flip has to be either a heads or a tails. It can't be different. It'll have to match one of the first 2. So here's an example. The probability is 0. And finally, the probability of 2 heads and a tail, we find those. There's 3 of them, all circled. That's 3 out of 8, or 3 to 8. The probability of flipping heads when you flip a coin is 1 out of 2. If you flip 2 coins, the probability of flipping heads twice in a row, you may remember, was 1 way out of 4. That can also be written as 1/2 times 1/2. And that works because when you flipped it the first time, you had a 1/2 chance of getting heads, and then when you flip it again, you have another 1/2 chance of getting heads. 1/2 times 1/2 is 1/4. Now let's flip a coin 3 times and see if we can get heads 3 times in a row. Well, if we remember from our list before, there were 8 ways, and only one of the ways was all 3 heads, 1 out of 8. But another way to get that would be 1/2 times 1/2 times 1/2, because for each flip, you have a 1/2 probability of flipping heads. So the probability of getting 3 heads in a row is 1/8. So let's expand on that and try to find the probability of getting all 10 questions correct on a true-false quiz by guessing. The probability of being correct on each problem is 1/2. But the probability of being correct on all 10 problems, we have to multiply that probability for each problem. And since there's 10 problems, it's 1/2 times itself 10 times, or 1/2 to the 10th power, which if carried out is a 1 over 1,024 probability of getting a perfect score by guessing on a 10-question true-false test. While you would likely get quite a few problems right, the probability of getting all 10 right is not so good. When the outcomes of a situation are equally likely, the probability of an event is the ratio of the number of outcomes in the event to the number of possible outcomes of the situation. Numbers used to represent probabilities range from 0 to 1. If an event must happen, the probability is 1. If an event cannot happen, the probability is 0. The probability of events happening one after the other can be determined by multiplying the probabilities of each event.